तो आज एक बहुत इंपॉर्टेंट एस्पेक्ट में घुसने वाले हैं, दैट इज गेम थ्योरी. नाउ गेम थ्योरी डील्स विद एनी सिचुएशन इन विच द रिवॉर्ड टू वन प्लेयर, which is called the payoff, depends on not only his or her actions but also on the other players actions. ठीक है. आज हम लोग दो गेम्स के बारे में देखेंगे. एक होता है साइमल्टेनियस मूव गेम एंड एक है सीक्वेंशियल मूव गेम. साइमल्टेनियस मूव गेम ऐसा गेम है जहां पर both the players have to act in the same time. An example of that is the prisoner's dilemma. ओके, जो हम लोग अभी देखने वाले हैं. ओके, तो एक सिंपल सा साइमल्टेनियस मूव गेम है प्रिजनर्स डिलेमा, जहां पर देर आर टू प्रिजनर्स. दे आर पुट इनटू टू डिफरेंट रूम्स एंड questioned. Depending on whether both confess to a particular crime, one confesses, the other does not confess, and both don't confess. So ये सारा payoff is put in a beautiful table like format, जहां पर the first number usually deals with the row player. I call this prisoner one as the row player and prisoner two as the column player. Okay. Now, row player ka payoff will always be given as the first number, and the column player ka payoff is the second number. So, for example, if the first player and the second player both are confessing, both are getting 3 years in prison. If the first is not confessing and the second is confessing, then the first one gets 10 years and the second one goes free, scot free. Okay. And similarly, confess and don't confess. First one confesses, the second one doesn't confess. First one goes free, and the second one takes 10 years. Okay. So that is what usually happens when it comes to these games where the role player has the first number as the payoff and the column player has the second number as the payoff. So the first number in each block indicates a number of years the first prisoner will be in the jail. The second number in each block indicates a number of years the second prisoner will be in jail. Okay. ठीक है. नाउ इसमें दो अच्छे कॉन्सेप्ट्स हैं. एक कॉन्सेप्ट है ऑफ अ डोमिनेंट स्ट्रैटेजी. डोमिनेंट स्ट्रैटेजी का मतलब है irrespective of what the other player is doing, it is always in my interest to take a particular action. So basically, that means that if you take a look at prisoner one confesses. If prisoner two confesses, prisoner one gets 3 years, and if prisoner one confesses, prisoner two doesn't confess, he goes free. Whereas prisoner 2 confesses, prisoner 1 does not confess, 10 years. Prisoner 2 doesn't confess, prisoner 1 also doesn't confess, 1 year. So 3 years is better than 10 years. Free is better than 1 year. So can I say that it is always better for prisoner 1 to use the action of confessing, because confessing is always having a lower term than don't confess. 3 years better than 10 years, free better than 1 year. Similarly, for the second person, 3 years better than 10 years, free better than 1 year. So it is a dominant strategy for both the prisoners to use confess. And this 3 years, 3 years is what will be the equilibrium. Okay. So, dominant strategy is a strategy which is strictly dominant for the player if the strategy gives the players I, if um, it is giving a payoff more than any other strategy. Okay. So that's a dominant strategy for the individual. And a dominated strategy is the one that you are eliminating. So don't confess is dominated by the strategy of confessing, right? ये जो डोंट कन्फेस है इट इज इंफीरियर टू कन्फेस. तो जो सुपीरियर है स्ट्रैटेजी उसको बोलते हैं डोमिनेंट, और जो इंफीरियर है उसको बोलते हैं डोमिनेटेड. ओके. Iterated, strictly dominated is an expression जहां पर I remove a dominated, then the other players also removes a dominated, right? So that's called an iterated dominated strategy. इसके बाद में जो एक और aspect है which I wanted to share, that is the concept of Nash equilibrium. Now, John Nash, in his wonderful research, basically says that this equilibrium is a result when every player in a game chooses the best response action or the best response strategy given the strategies of other players, ignoring the effects of his or her action on the payoffs received by those other players. Okay. So this is the definition of Nash equilibrium. The strategy profile is a Nash equilibrium when it is a best response for all player. Okay. So here also best response may 3-3 is called the best response in this game, because if prisoner 1 is confessing, prisoner 2, 3 years is better than 10 years. So prisoner 2 should also confess. And if prisoner 2 is confessing, 3 years is better than 10 years for prisoner 1. So prisoner 1 should also confess. So starting with prisoner 1, doing confessing, prisoner 2 should confess. Then starting with prisoner 2 confessing, I'm coming back to prisoner 1 confessing. So confess is the best response strategy, best response strategy, and hence this 3-3 is the Nash equilibrium in this game. This concept of best response strategy was first put forward by John Nash, and it's named after him as called the Nash equilibrium. Okay. ये सब का एग्जाम्पल लेने से आपको बहुत अच्छे से समझ में आएगा. एग्जाम्पल हम लोग लेंगे बाय डूइंग अ फ्यू प्रॉब्लम्स, उससे आपको समझ में आ जाएगा व्हाट हैज टू बी डन. ओके. So multiple questions है. We'll take a look at a few ISI questions that will make you more comfortable. सही है, questions में चले. So this is ISI 2019 PA question number 30. Two players P1 and P2 are playing a game which involves filling the entries of n cross n matrix. So there is a matrix n cross n. You are filling the parts in that, the numbers in that. And n is an even number. So let's take an example of 4 by 4. Okay. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. So these are the 4 by 4 for the matrix. Starting with player 1, that is Punya. Each player takes turn to fill an unfilled entry of the matrix with a real number. The game ends when all the entries are filled. Player 1 wins if the determinant of the final matrix is non-zero. Player 2 wins if it is equal to 0. So player 1 wins when the determinant value is not equal to 0. Player 2 wins if the determinant value is equal to 0. A player I has a winning strategy if, irrespective of what the other player does, I will win by following this. Which of the following is true? Okay. So, Punya, your P1, which one do you want to fill?
Uh, I'll fill the one by one.
Okay.
So I that like
Number?
7.
Okay. Apurva, can you choose a number? Where do you want to fill it?
So I'll fill 1, 2.
Huh? 1 by 2. This one.
Yes, sir.
By what number?
5.
5. Punya, what about you?
So, 3 by 2 with 8.
3 by 2 with 8. Am I right?
Yeah.
Okay. Apurva, what about you?
So 1 into 3 by 3.
Okay. Punya,
Uh, so, 3 into 3 with 7.
okay. Apurva,
So 1 into 4 by 2.
okay. Let's go quickly. Okay. Punya,
Yeah. 3 by 3 with 9.
3 by 3. This is
Sorry,
3
3
by
by 4. 3 by 4.
3 by 4 by 9. Okay.
So 2 into 1 by 1.
Uh,
Punya,
2 into 2 with 12.
okay. Are you guys actually filling this absolutely randomly, or is there any thought behind it? Okay. Once you do it, I'll ask. Okay. Apurva, now your
2
turn.
in 2 into 3 by 5.
Okay. Punya,
Uh, 2 into 4 with 1.
okay. Apurva,
0. 4 into
which
1.
one? Huh?
4 into 1 by 0.
4 into 1 by 0. Okay.
Sir, 1 into 3 with, let's just say like 6.
6. Okay. Apurva,
4 into 4 by 0 again.
0. Okay. You
Uh,
need to make the determinant equal to 0. Okay. Punya,
uh, 4 by 2 with, just say 3.
last number, Apurva.
So 1.
Okay. अब इसका डिटर्मिनेंट वैल्यू निकालेंगे कोई. सो इसका डिटर्मिनेंट वैल्यू बिकम्स 540. एंड हु इज द विनर? पुण्य इज द विनर. Congratulations, Punya. But I would also want to understand by both of you, were you thinking कि कुछ आपको लगाना है strategy इसमें? Apurva, can you go first? How were you responding to Punya's numbers?
So I was trying to make the lower matrix 0. The triangular, lower triangular 0.
Lower triangular matrix to be 0. How will... But if you make the lower triangular matrix to be 0, that does not ensure that the determinant value overall is equal to 0. If the lower triangular is equal to 0, then the determinant value is simply the product of the diagonals. So if 0 is here, but how will you get everything to be equal to 0 here? Punya will
The,
not allow that.
then, then I thought that if we expand by row 4, then everything would be 0. If I make the lower triangular matrix 0, then if we expand by the last row, then we get determinant 0.
Okay. Punya, any
Uh,
strategy that you
I
thought?
was just ensuring that the z if they were going with like trying to place zeros in the optimal spots, they can't try to put it there, and ensuring there's no multiples of numbers across 2 rows or columns specifically, because then if one row or column is a multiple of another, then that would ensure the determinant is 0. So just trying to go with that.
Hmm. Yeah. Yeah, that's correct, Shritama. Right. Okay, Punya, will you want to play with me? I am player two. Okay. You can be player one. The winner plays with me. Okay. So that was a rule of the game, which I forgot to say, but now I'm saying it. Okay. Punya, can you start again?
1 by 1 with 4.
4. 4. Next.
Uh, okay, I can see where this is going.
Now.
Uh, 2 by 3 with 12.
Okay. Next.
Uh, 3 by 2 with 7.
3 by 2 with 7. Okay. Next.
1 by 4 with 8.
This 8.
Yes.
8. Next.
Then 2 by 2 with 3.
3. Next.
Then 3 by 4 with 9.
3 by 4 with 9. 9. Okay. Next.
And 2 by 4 with 1.
1. So now two of the columns are the same. So then the value of the determinant is equal to 0. So you got the strategy that I did. I was basically replicating whatever you did. I tried to replicate it in any one of the columns or any one of the rows. Here I chose to replicate in the column, but you can also choose to replicate in the row. If two rows or two columns are the same, the value of the determinant is equal to 0. Does everyone actually know this? If you know this, type K in the chat box. Do all of you know this? Punya, did you get what I did?
Yes, sir, I understood pretty much instantly.
Right. So, what the second player has to do is to basically copy the first player. He will copy the first player and make two columns or two rows to be equal to 0. Once he does that, the value of the determinant is equal to 0 and he ensures that he wins. So, player number 2 has a winning strategy irrespective of what player 1 is doing. So player 2 has a winning strategy. That's B. That's the answer, which is what majority of you've got. That's good. But I hope that the ones who did not understand the question, they have now understood how to attempt and what is the strategy in this game. Clear with everyone? If it is, type C in the chat box. तो गेम इज अ टॉपिक जहां पर हमें गेम खेलना पड़ेगा. ओके. So how many of you are willing to play more games today? If you are, type G in the chat box. चलो और गेम्स अभी खेलेंगे. So this is ISI 2008, question number 9. Consider the following box with 16 squares. There are two players, player 1 and player 2. Again, player 1 and player 2. And the game begins with player 1 selecting one of the boxes marked 1 to 16. Following such a selection, the selected box, as well as all the boxes in the square of which the selected box constitutes the leftmost and the lowest corner, will be deleted. So if someone chooses, say, the number 6 is the leftmost and the lowest corner. So this entire thing will get deleted if 6 is chosen. If supposing 9 is chosen, then everything here, this will be deleted. This is what they are saying. For example, if he selects box 7, then all the boxes 3, 4, 7, 8 will be deleted. Similarly, if he selects box 9, then all the boxes 1 to 12 are deleted. They are also giving you an example. Next, it is player two's turn to select a box from the remaining boxes. The same deletion rule also applies for player 2. It is then player one's turn again, and so on. Whoever deletes the last box loses the game. What is the winning strategy for player one in this game? This is what the entire question is. Okay. Uh, Sharanya, is this okay now? You were having a doubt. Can you please unmute yourself?
Yes, sir. With regards to the question, like when solving it, sir, could I play the game to better explain my doubt?
Right. Okay. So you can play the game, Sharanya. So keep yourself unmuted. I give you an opportunity to choose either player one or player two. So
Player
whom do you
one,
want to
sir.
be?
Player one.
Player one. Okay. Um, Swati, can you unmute? Swati,
Sir, there's still the noise going.
there is still the noise issue. Okay. So that's okay. Can you put it in chat also? Everyone will not be able to see.
Oh,
Okay. Any other volunteers who don't know the game? Who don't know the game? You're seeing the game for the first time today. Uh, Roopsha, can you unmute yourself?
Yes, sir.
Yeah. Uh, you know how to play the game. Have you found out an answer yet?
No, sir.
Very good. Good. Okay. So player one is Sharanya. Player two is Roopsha. Sharanya, can you please unmute yourself?
Yes, sir.
Great. Awesome. So what do you delete first? Giving
10.
you the chance. You're deleting 10. Okay. So 10, if you delete, then this entire thing will go. Right? Sharanya?
Right, sir.
Okay. Roopsha, what do you do?
Sir, I'll delete 9.
Okay. So if you delete 9, so all of this will go. Okay. So 10 and then 9. Okay.
So 14.
14. Now Rupsha.
13.
So who loses the game?
I lose.
Right. So Sharanya, so what was your doubt here?
Right, so my doubt with regards to this was, say, Rupsha chose 9 when it was her turn. So I was wondering, since 9 isn't like, we just have the first row and the first column and the last row left once, the first player calls 10. Does choosing 9 imply simply the 9 ka box gets cancelled, or does that imply the entire, like, the numbers above
No, no,
9
the
also get
same
cancelled?
deletion rule applies.
No, sir, but it's not a square, right? It's the lowest.
Leftmost. So this entire thing is gone. So
Yeah, but 9
now
is not the
if I choose,
leftmost number for anything. It's the lowest for 1 and 5, but it's not the leftmost for anything. So,
no, so it is the leftmost for this thing itself automatically. And it is the lowest corner, lowest and leftmost. So, leftmost, it is already there because all of this is gone. So, lowest corner will be this is the thing. So,
so,
that has to be
so
considered.
then that would constitute a winning strategy for player 1, right? So if player 1 chooses 10, and no matter what player 2 chooses after, player 1 can always win because they can manipulate player 2 into, like, choosing the last box. Every outcome would end in player 2 choosing the final box.
Right, right. So, you're fine. Roopsha, will you like to try the game again? Any other volunteers?
Sir, if I chose 13
Yeah, so I'll come to you.
also, then also, like, I would only end up losing.
I'll no, I'll come to you. We'll play the game once more. Anyone else wanting to play the game? Punya, would you want to play the game once more?
Sure.
So, Roopsha, which one? Player one or player two?
It's a player 1.
Player one. Okay. Uh, okay. So now what do you choose? Player one.
11.
Huh?
11, sir.
11. You choose 11. So if you choose 11, so all of this will go. Punya, what do you choose?
So 15.
15. So all of this will go. Roopsha, your turn again.
6.
6. So all of this will go. Punya,
For 5.
5. So all of this will go. Roopsha, once more.
10.
10.
Yes, sir.
So this will go. Punya,
So 13. Wait, no, sorry, not 13, 13, not 13. I got confused again. Actually had the same doubt as Sharanya, so I got, yeah, oh,
yeah,
9.
you choose 9, so this will go. That's it. Rupsha,
14.
14, and
13.
Punya loses, unfortunately. Okay, so, but both of you were not playing appropriately. Both of you were not playing appropriately. You'll understand how to play appropriately if Sharanya plays once more. Okay. Sharanya, can you unmute yourself?
Yes, sir. Sure.
Punya, can you be player 2 again so that everyone can now see what is happening once more? Okay. Sharanya,
Right,
choose.
sir. So I choose
Choose
10 again.
10. Okay. Choose 10, and this is gone. Punya,
So 9.
9. This goes.
Yeah, same thing.
So it's the
Sharon.
same. I choose 14 again.
Right. So what is happening is player one should first choose 10. Okay. Make the game in a way that only this first column and the last row is only remaining. Player one should make it that only this should be remaining. Then player two, Punya, can you choose any other number other than a 9?
So 16.
16. You choose 16. Sharanya, what do you do now?
So I could choose 13.
13, then it's gone.
No, sir, but then Punya could play something. I mean, if I
Yeah,
play.
I can play 5 then, and then you'll have to choose
Oh,
9.
sir,
No,
if
no,
I
no,
play
no, that's
13, does
fine.
that
No, no,
imply
that's
1 to
fine.
13?
Huh?
Oh, does that imply both the first column and the 13 to 15 are gone?
If you choose 13, then everything will be
Right,
gone.
right, right. Got it, sir. Okay, so then 14.
You'll choose 14. Okay, so you also haven't fully understood the game. Okay,
So
14,
9.
gone. Punya chooses 9 and you lose, Sharanya.
Right.
Okay, so again, first strategy is okay, Sharanya. The next ones are not quite fine. Okay. Uh, Punya, uh, if you choose 16 and I, supposing, take over, I will choose 1. Okay. Now you choose.
So 14
You choose 14. I'll choose 9.
and 13.
13. Right. So, what player 1 should do? Player 1 first plays 10. Okay. Then, whatever player 2 does, if player 2 is choosing, say, 15, player 1 chooses the diametrically opposite number here. 15 chosen, you choose 5. So all of this will go. Then whatever you choose, whether you choose a 9, if you choose a 9, I choose a 14, and ultimately you will have to choose 13 and it's all over. So basically what is the strategy is that first player does 10, that is a no brainer. Whatever player 2 does, supposing these are all A11, A21, 31, 41, 42, 43, 44. If 21 is chosen by player 2, then player 1 should choose 43. इसके बदले में ये, if 1 is chosen, then 4 should be chosen. So the number which is right opposite in the last row. Okay. Right. So if A11 is chosen, A44 will be chosen. If A21 is chosen, A43 will be chosen. If A31 is chosen, A42 will be chosen. Correct? And what will ultimately happen is player 2 will always be left with 13 in the end. Okay? Shrishti and Ankit, what do you want to say? Have you understood the game now? Shrishti. Shrishti.
Yes, sir.
Yes, sir, I understood. I just wanted to play after that. It's fine.
Okay.
Same
Okay.
here.
So I hope all of you have been able to understand what is happening here, right? And player one has a winning strategy in this game. Thank you to all the participants. And I hope that all of you have been able to understand what had to be done in
Sir,
this game. Yeah.
sir, is there a common way to find out the winning strategy? Like if it was instead of 16, if it was 20, is there a strategy we can use?
See, if it would have been 20, then see, all these strategies usually work with even number. And um, here it is about elimination. Whenever elimination comes, it gives an advantage to the first player, usually. Okay. So, do you want to play a very similar game once more? How to write solutions? You write all this, whatever I shared, you write it. Supposing player 2 chooses A11, player 1 should choose A44. Similarly, A31, player 1 should then choose A42. You have to write all this in your answer, Shivank. The examiner should understand what you are trying to say. Okay. It may not be a very lengthy solution, but the examiner understands that you are correct. They will give you full marks. As simple as that.